we discuss the solution of a problem from the section Quadratic Equations. The problem is on roots of a quadratic equation. This problem has appeared in JEE Main examination held on 25th July 2021 in the shift 1. The problem is, if alpha, beta are the roots of the equation x square plus 5 root 2 x plus 10 is equal to 0, where alpha greater than beta and Pn is equal to alpha power n minus beta power n for each positive integer n, then the value of the quotient, whose numerator is P17 P20 plus 5 root 2 P17 P19 by the denominator P18 P19 plus 5 root 2 times P18 square is equal to. We now discuss the solution of the problem. We are given with alpha, beta are the roots of this quadratic equation x square plus 5 root 2 x plus 10 is equal to 0, where alpha greater than beta and Pn is equal to alpha power n minus beta power n for all n belongs to the set of natural numbers. First of all, we note down that alpha and beta are not 0. Had they been 0, then there would have no constant term in the quadratic equation. Therefore, neither of alpha beta is 0. Now, we take the quotient P17 P20 plus 5 root 2 P17 P19, that is the numerator, by the denominator P18 P19 plus 5 root 2 P18 square is equal to, in the numerator we take P17 common, in the denominator we take P18 common, and we write down the quotient. Now, after seeing this P20 plus 5 root 2 P19 and P19 plus 5 root 2 P18, this is something to do with the equation, and we try out what happens to Pn when we look at this quadratic equation. So, alpha is a root of this equation. Therefore, alpha satisfies this quadratic equation. That implies alpha square plus 5 root 2 alpha plus 10 is equal to 0. And n is a positive integer, multiply throughout by alpha to the power of n minus 2, so that we get alpha power n. Multiplying throughout by alpha to the power of n minus 2, we get alpha to the power of n plus 5 root 2 into alpha to the power of n minus 1 plus 10 times alpha to the power of n minus 2 is equal to 0. Let us call this as the equation 1. So also for the beta, since beta is a root of this equation, we also get an equation like beta power n plus 5 root 2 beta to the power of n minus 1 plus 10 times beta to the power of n minus 2 is equal to 0. Let's call this equation 2, and we get this equation similarly as above. Now, subtract the equation 2 from 1, so that we get alpha power n minus beta power n. And subtracting equation 2 from equation 1, we get alpha power n minus beta power n plus 5 root 2 times alpha power n minus 1 minus beta to the power of n minus 1 plus 10 times alpha to the power of n minus 2 minus beta to the power of n minus 2 is equal to 0. Now, alpha to the power of n minus 1 minus beta power n is Pn, and this is Pn minus 1, this is Pn minus 2. Therefore, we get Pn plus 5 root 2 Pn minus 1 plus 10 times Pn minus 2 is equal to 0 for all n belongs to n. Now this implies Pn plus 5 root 2 Pn minus 1 is equal to minus 10 times Pn minus 2 for all n belongs to n. Now we see P20 plus 5 root 2 P19 in this. So if n is equal to 20, you will get an answer from here, and in the denominator, when n is equal to 19, we will get an answer from here. So those things we substitute here and try to get simplification. We have so far, this is the quotient what we have. P17, P18, P17 is taken common in the numerator, P18 is taken the common in the denominator, and we got this equation, Pn plus 5 root 2 Pn minus 1 is equal to minus 10 times Pn minus 2 for all n belongs to n. So take n is equal to 20 here, P20 plus 5 root 2 P19 is equal to minus 10 P18 for this. And take n is equal to 19, n is equal to 19, we get P19 plus 5 root 2 P18 is equal to minus 10 times P17. So substitute in the above. We get, that is the quotient. That's what we have taken after taking the common factor P17 in the numerator and P18 in the denominator. And now P20 plus 5 root 2 P19 is minus 10 P18. And P19 plus 5 root 2 P18 is minus 10 times P17. Substitute and cancel off minus 10 minus 10, and we have P17 P18 by P18 P17 and cancel off that is equal to 1. That's the answer. So the answer for this question is 1. That's the solution of that problem. Yes. I will explain. There is an alternate method for solving this problem. I will go for it and I will explain that later. We are given with alpha, beta are the roots of this quadratic equation. Alpha is greater than beta. Neither of these alpha, beta is 0. And Pn is equal to alpha power n minus beta power n for all n belongs to n. Now take the quotient, and as before, take P17 common in the numerator, P18 common in the denominator, and write down for P20 alpha power 20 minus beta power 20, for P19 alpha power 19 minus beta power 19, so also in the denominator for P19 and P18 write down. Now in the numerator, alpha power 20 and 5 root 2 alpha power 19, and take alpha power 19 common, we will get alpha plus 5 root 2 alpha. And so also beta power 20 and 5 root 2 beta power 19, beta power 19 take common, we will get beta plus 5 root 2 we will get. So we will get these things. So similarly in the denominator. Now we go and see alpha is a root of this equation, and alpha satisfies this equation, and alpha square plus 5 root 2 alpha plus 10 is equal to 0. Alpha times alpha plus 5 root 2 is equal to minus 10. Therefore alpha plus 5 root 2 is minus 10 by alpha. No worries, alpha sitting in the denominator, alpha not equal to 0 we have already noted. And similarly for beta also you will get a similar expression, beta plus 5 root 2 is equal to minus 10 by beta, and go back and substitute in the above. We do it in the next slide. Alpha is the root, we will get alpha plus 5 root 2 is equal to minus 10 by alpha. Beta is the root, beta plus 5 root 2 is equal to minus 10 by beta. So go back and substitute. Alpha plus 5 root 2 is minus 10 by alpha. Beta plus 5 root 2 is minus 10 by beta. Substitute in this. You will get P17 into alpha power 19 into alpha plus 5 root 2 is minus 10 by alpha minus beta power 19 into minus 10 by beta, and in the denominator P18 bracket inside alpha power 18 minus 10 by alpha for this minus beta power 18 into minus 10 by beta. So we take out minus 10 common, minus 10 in the denominator, minus 10 in the numerator. P17 into alpha power 19 by alpha is alpha power 18, beta power 19 by beta is beta power 18, so also in the denominator. You will get minus 10 P17 into alpha power 18 minus beta power 18 in the numerator. Denominator minus 10 P18 into alpha power 17 minus beta power 17, and alpha power 18 minus beta power 18 is P18 and this is P17. Substitute, and minus 10 cancels. P17 P18 by P18 P17, that is equal to 1. That's your answer. Thus we have come to the end of the discussion of the problem in two different methods. And I hope that you have understood the solution of the problem, and I wish you all the best. Thank you.